So today we will talk about the earthquake. And yesterday, I showed you the animation about the structure of the Earth and the crust, the mantle, and the core. So okay, so I give you a small quiz. So which one is the outer layer of the Earth? Can you type the answer? Which one is the outer layer of the Earth? Which one is the outer layer of the Earth? Please type your answer. Which one is the outer layer of the Earth? Crust or core? Which one is the outer layer? Yeah, John Paul, very good. The inner is the core, and then the outermost layer is the crust. Okay, so here, wait, no. So let us look at the okay. So what is the structure of the Earth? So here, okay, the core, okay, and then this is the mantle, and then the surface is covered by the crust. So plates. So the crust is composed of different solid rock pieces, and these rock pieces, plates, are the components of the crust. So there are crust, the outermost layer of the Earth. Okay, it's just like the how can I say? That means in Chinese we call the I mean the cover of the Earth. Do you understand? Plates are the cover of the Earth. Do you understand? The cover. So it's the outermost layer, okay? The layer which covers the Earth, the plates. Okay, so the plates are movable. So there are 1, 2, 3, 4, 5. There are 7 major plates. Okay, 7 major plates. Eurasian, okay, Europe and Asia, African, Indo-Australian, Pacific, North American, South American, and Antarctic plate. This is also a plate. You know that here, Japan is on the plate boundary. So earthquake always happen in Japan. And then you see Taiwan is along the plate boundary. So earthquakes always happen in Taiwan as well. And then you see the North America, the West Coast, California are also along the plate boundary. So that's why earthquakes always happen in West America, in California. Okay, so plates form the land surface and ocean beds. Okay, so do you know why plates move? Do you know why there is plate movement? Which layer is responsible for the plate movement? Which layer? Core, mantle. Which layer is responsible for the plate movement? Core or mantle? Please type your answer. Core or mantle? Which layer is responsible for the plate movement? Yeah, mantle. Yes, mantle. Yeah, mantle is responsible for the plate movement because there is convection current. It's just like a bottle of boiling water. Okay, you see the water current. Okay, going up and going down, rising and falling. So this is the convection current in the plate. Okay, so let's go to the next slide. Okay, so okay, so the area where 2 plates meet is called the plate boundaries. Okay, so plate movement are driven by convection currents in the mantle. Here, okay, is the convection current. The current rises, the current falls. Okay, it's a current. Okay, you can say it's a cycle. Okay, so the heat. Okay, the heat from the core drives the correct convection currents. Okay, so so I show you the video about the mantle. Okay,
Mantle.
Yeah, mantle. Yeah, it's called the mantle. Okay, this is the convection current video. Let us watch it. Oh, Yeah, the movement of plates is driven by the convection currents in the mantle, you see, okay? The movement of currents. And then, so the area near the core, okay, is very hot. So the mantle rises, okay? And here, a mantle cools near the crust, so it sinks. And then, so when the mantle falls back to the core, it is heated again, so it rises, okay? So it's a current. So the up and down movement of the mantle forms the convection currents, okay, that drives the plates to move. Yes, and do you think the plates, okay, I mean the crust will grow? Do you think the crust will grow over the years? Do you think the crust will grow over the years? Yes or no? The crust will grow over the year. I think, okay, it's no. Why? Because when some places, okay, when there is a growth of plate, in some places, some plates are destroyed, okay, because of the movement. So you know, where in collisions, some plates are driven down and destroyed. Okay, and in some other places, the plates rise up and are formed. So it's a process, okay, with production and also the destroy of plates in equal measure. Okay, so let's go to the PowerPoint. Okay, so here. Okay, so let's do some revision, okay, here. Okay, so the Earth is divided into 3 layers. So please answer the question first, okay? The Earth is divided into 3 layers. So what are the 3 layers? So what are the 3 layers of the Earth? Okay, so let's look at the answer. Crust, mantle, and core. Okay, next. The crust is composed of several large rocks pieces called, how do we call the large rock pieces? And then the area where 2 plates meet is called what? And then the movement of plates is driven by what in the mantle? Please type your answer. Yeah, crust, mantle, or plate. So the rock pieces are plate. So what is the movement? Okay, where the plates meet? What is the area? It's not the crack. It's not the crack. It's not the crack. Let me check it. Okay. Okay, you see the PowerPoint here. Okay, so plate boundary. Remember. Okay, of course, I call it a crack, but it's not. It's informal. Or crack is informal. Okay, I don't understand the concept, but in geographical terms, we call it a plate boundary. Okay. Yeah. So plate boundary, and then the movement of plates is driven by convection currents. Okay. Well, remember these key terms: crust, mantle, core, plates, a plate boundary, convection currents. These are the key terms. Okay, next. Why do earthquakes occur? So earthquakes occur because of convection currents and plate movement. Okay, so there are 3 types of plate movement. So this is the okay, this is convergent. Okay, the first type is convergent, means move things towards together. Okay, the first type is convergent. Okay,
Can you go back a little?
You want to go back to the previous slide. Okay, let's go back to the previous slide. It's okay. Okay, here. This is the previous slide. Okay, can you see it? Oh, can you see it? Charmaine, can you see it? Yeah.
Yeah.
Okay, then go to the next slide. Okay, it is by convection currents and plate movement. Can you see it? Convection currents and plate movement here. Okay. So next we will go to 3 types of plate movement. This is moving towards each other. It's called convergent plate. Convergent. Convergent. I type for you. Convergent. Convergent. Okay. And then for the plates moving away, this is the moving away from each other. For the plates moving away from each other, we call it a divergent. 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 And then the 3rd type is horizontal. Horizontal movement. Okay. Divergent. Horizontal means sliding past each other. Okay. So these are caused by convection currents. And these 3 types of plate movement can trigger earthquakes. So here, the animation will show you different types of plate movement. Okay, so I'm going to show you the video. Okay, this is the videos. Okay, so this is the convection current. Okay, so convergent plate movement when plates are moving towards each other. So one plate subsided. Okay, and then this is the horizontal movement. Okay, this is the divergent movement. You see the currents are moving away. So that's why the plates are moving apart from each other is the divergent movement. And this is sliding past, okay, sliding past each other. Okay, just horizontal movement. Okay, so let's go back to the PowerPoint. Okay, so here. Okay, so here. Okay, so here. Now this is the cause of the earthquake. So I'm going to show you another animation. Okay, causes of the earthquake. Okay, so here it is the causes of the earthquake. Okay, so the plates are moved by convection current. Okay, 對流啦，記住呢啲對流嘅熔岩 convection currents. And then pressure the key term is pressure. Pressure builds up along plate boundaries. Pressure is the key terms. Without pressure, there is no earthquake. So pressure builds up along plate boundaries. Large pressure causes plates to displace suddenly and break the rocks. Okay, so here, large pressure. So the plates displace, move, okay? And then sudden movement breaks the rocks, so it causes earthquake. So pressure causes displacement, sudden displacement, and then the rocks are broken, break the rocks. Okay, so this is the focus. Okay, 震央，我哋中文講震央 the focus where the energy, okay, is released. Okay, the point where a plate is places and the energy is released is called the focus. Remember, focus is the keyword, focus. And then this is epicenter. Okay, epicenter. So the point on the ground surface vertically above the focus 我哋講震央即係話嗰個地面 ，OK, I mean the ground surface directly vertically above the focus. So it is the hardest hit area. This area suffers the most serious devastation. Okay, and then seismic wave 嗰個震波 energy released from the focus and travels in all directions. Okay, so seismic wave. So 3 key terms. Okay, focus, epicenter, seismic wave. Okay, remember these 3 terms. Okay, next, we'll go back to the PowerPoint. Okay, so the distribution of earthquakes. So earthquakes mainly occur along the plate boundaries. Okay, so now these arrows show the movement of plates. Okay, and fortunately, Hong Kong is it's not very far, but I think it's to a certain degree. Okay, it's not on the plate boundary, so earthquakes do not always happen in Hong Kong. Okay, but for Taiwan, okay, and Japan, these are prone to earthquakes. Okay, so the orange dots show the earthquake area. So you see Japan, okay, is covered by the orange dots. Okay, and then the northern China is also covered by orange dots too. Okay, so main earthquake zones. So here, the Pacific region. Okay, Chile, America, Western America, California, Japan, Taiwan, the Philippines. Okay, and then Indonesia, Eurasian, Tibet, Turkey. An earthquake happened in Turkey about half a year ago. So Turkey is on the plate boundaries. Okay, and then the Alps. Okay, Aibeitishan in Switzerland is also prone to earthquake. So the most famous earthquake zone is Circum-Pacific Belt, and then it has a nickname called the Pacific Ring of Fire. Why do we call it a Pacific Ring of Fire? There are many volcanoes in Japan. Mount Fuji is a dead volcano, but it was an active volcano before. And there are many active volcanoes in Japan. And then the plasma, the plasma from the volcanoes can heat up the water. That's why there are many springs in Japan. Okay, so fire means the mantle, okay, the plasma, okay, from the earth. So the Pacific Ring of Fire, and it covers, okay, the Pacific Belt covers 90% of the world's earthquakes. Okay, so here another is Alpine Humanian Belt. It's the second largest earthquake zone. So the Tibet, okay, is at a very high altitude, 5,000 meters above the earth. Because why is this place elevated above the earth? This is because it's on the plate boundary. So the movement pushed the place above, pushed the plate upward. Okay, so it's remember, Circum-Pacific Belt, Alpine Humanian Belt. These are the two key terms or two key earthquake zones. So what are the negative effects of earthquakes? Okay, so first of all, we need to measure the strength of earthquakes. So this is although it likes Richter, but it's not Richter, it's Richter scale, not which, Richter scale. And it shows the magnitude. Magnitude means the strength. Magnitude means the strength. Okay. Now, any questions until now? Any questions until now? Okay. So if you have no question, we can go on. So like this is the Richter scale. So you see the strength increases exponentially very quickly up beyond level 6. So let's look at the graph. The higher the magnitude, the more powerful the earthquake is. Okay. So here, let's look at the graph. Okay. So if the magnitude is between 1, if the magnitude is between 1 and 2.9, it can only be detected by seismometers. 地震記錄儀 seismometers, okay? 地震記錄儀 But if the magnitude increases to 3 and to 3.9, the strength is felt by persons on upper floors of tall buildings. Okay, that's why sometimes Hong Kong people may feel the impact of earthquakes because the buildings in Hong Kong are very tall. Okay, and then if the magnitude increases to 4 to 5.9, it is felt by everyone. And then poorly built structures like the squatters or poorly maintained buildings will be damaged. And then if the strength increases to 6 to 8.9, there will be widespread damage and some buildings will collapse. And then if the magnitude increases to 9 or above, the ground is badly cracked, and then almost total destruction. So so I think, do you remember a century ago in 1910, San Francisco, okay, was devastated by an earthquake, okay, at the magnitude of 9 or 9.5. So the whole San Francisco was destroyed, okay. Yeah, so here, okay, so these are the impacts of earthquakes, okay, so earthquakes of high magnitude usually cause loss of lives and property, okay? And then here, the impacts, okay, can be divided into primary effects and secondary effects. Remember, primary effects and secondary effects, okay? So what are primary effects? So the primary means immediate and direct destruction as a result of ground shaking. So here you see the graph, okay? Immediately the buildings collapsed, okay? And then infrastructure and communication networks damaged, okay? You see the pole, okay? The pole here. And then aftershocks, 余震 caused further destruction, okay? So what these are the first primary effects. So what are secondary effects? So these are the damages caused by primary shaking effects. So what is this? Okay, so for example, maybe the tsunami. Okay, the tsunami is also an example of secondary ground effects. Okay, so anyone tell me other examples of secondary effects? Other examples of secondary effects apart from the tsunami? I think the effect was covered by us 1 or 2 lessons ago. If you live near the hillside, these secondary effects will affect you. Yeah. What is the example of effect? If you live near a hill, this effect will definitely affect you. I mean, a lesson or 2 lessons ago, what were we talking about? It begins with L. It begins with L. What is this? Landward. 如果你住喺山邊咧，如果地震咧，你就麻煩啦。咁如果住喺山邊有啲咩會出現啊？Yeah, landslides, good, landslides. Landslides. Good. So there are two examples. Sorry? You Charmaine, you have the answer, so can you tell me your answer? Apart from landslides, what is another secondary effect? What is another secondary effect? Now, the first one is landslide. Yeah, tsunami, of course, tsunami. Yeah, tsunami. So, do you think, okay, so can you tell me an example of a country hidden? Can you tell me an example of a country devastated by the tsunami after an earthquake? Yeah, Japan. Yeah, Japan. 9 years ago. Okay, so the earthquakes spread through the coastal areas of Japan. So that's why the Japanese people uh, are used to the destruction of earthquakes. And then later I will talk about how the Japanese people design the building so that the degree of damage can be reduced. Okay, so remember the two secondary effects, landslides and tsunami. Okay, so here. So if an earthquake affects Hong Kong, how will it affect us? So how will an earthquake affect Hong Kong? Do you think buildings will collapse in Hong Kong because of an earthquake? Do you think buildings will collapse when an earthquake happens in the areas near Hong Kong? Yes or no? Yes or no? Yeah, it depends. Yeah, I think yeah. Although Hong Kong buildings are very tall, good point raised by Paul. Yeah, I mean tall buildings can cause severe damage when an earthquake strikes a city, but Hong Kong is not along the plate boundary, so the magnitude. Okay, now I mean the magnitude is the key factor. Magnitude, though the strength of an earthquake. Because Hong Kong is far away from the plate boundary, the magnitude, the strength of an earthquake is not very strong. Result, even a very strong, a very powerful earthquake happens, most we can feel is the vibration. Okay, I once felt the vibration caused by the earthquake when I was asleep. Okay, and of course I felt very scared. But the shaking of but the building, okay, did not shake. Okay, I just felt the vibration. So yeah, so I think Hong Kong is a very fortunate place. It is situated away from the plate boundary. Right. Hong Kong has not suffered from any devastation from earthquakes for as long as you can think. Okay, so Hong Kong is a very fortunate place, but Taiwan is not so fortunate at all. And I think maybe in 1999, okay, Taiwan was struck by earthquake and many buildings collapsed in Taipei City. Okay, and then if you Chinese literature, yeah, there's a book called 寒山大地震, an earthquake. Okay, and then I think in after 2000, an earthquake happened in Sichuan. Okay, in Sichuan, because Sichuan is also along the plate boundary, so you can say that hilly areas, mountainous areas are mostly along plate boundaries. Why? Because the movement of place push the land layers up. You can say the land layers up. As a result, mountains or plateaus, okay, or some of mountains are formed. You can say mountains were formed because of plate movements. Okay, mountains were formed because of plate movement. So if you go to hilly areas, these areas are mostly prone to the destruction of earthquake. Okay, so today we will conclude this lesson with this question. So does time matter when an earthquake strikes an area? So does time matter? So if an earthquake happens in the afternoon or at midnight, will the number of casualty be reduced? Okay, will the loss of life be reduced if an earthquake happens in the afternoon? So tell me your answer, and then why? Okay, let's look at the conversation. Yeah, so good. John Paul, very good. At midnight, most people are sleeping, so that's why they cannot leave the buildings. They cannot run to safety areas. But in the afternoon, people are awake, so they can respond quickly. But at night, people cannot respond because they are sleeping. So that's why when an earthquake strikes a place at midnight, the casualties will be much higher. Okay. Okay, so that's all for today's lesson. So next lesson I will talk about how to prevent, how to reduce the casualties in earthquakes. So thank you.